there's another type of solving by substitution, and there's kind of two ways to think about this next type. And one of the ways is using this property, this mathematical property, called the transitive property. And this becomes a really important one in geometry next year. The transitive property says, if I know, for example, if A equals B, so I don't know what A is, I don't know what B is, but let's say A is 5, then I would know B is 5, right? Or if A is -7, then B is -7, whatever it is, right? And B equals C, then what can I conclude? Let's look. Let's say A is 5, right? Then what does B equal? Well, B would also equal 5 because A is equal to B. And then what does C equal? Well, we said A was 5, so then B must be 5. So then if B is 5, then C must be 5, right? And so we notice they're all the same value, right? So what we can conclude is that if A equals B, and this same B, right, see the B? This same B is also equal to C, then we can conclude that A is equal to C. Okay, it's called the transitive property. It's a really important one. And here's just like a sort of real life example of it, right? Like let's say if Bob and Jim are the same height, or have the same amount of money, or the same cookies, or right, whatever. If Bob and Jim are somehow equal, right, just like A was equal to B. And we also know that Gary and Jim are the same height. Then what can we conclude? Well, let's see. So Bob and Jim are the same height. So here's Bob, right? Let's say Bob is, I don't know, 6 feet tall. Jim is also 6 feet tall. Oh, hey, look, here's Jim again. Here's that same name, right? So Jim, we already decided Jim was 6 feet tall. And so this Jim, it's the same Jim, must also be 6 feet tall. So then Gary must be 6 feet tall too, right? Because Gary is also the same height as Jim. So we've already known that Bob and Gary, they're both the same height as Jim. So they must be the same height as each other, right? We can conclude that if both Bob and Gary are the same height as Jim, then they must be the same height as each other, right? Same as if we know that both A and C were both equal to B, right? If they're both equal to B, then we know that they're equal to each other, okay? So just keep the transitive property in mind. It's definitely one way to think about this next problem. So here we're going to solve by, it's still called substitution when we do this, but another way to describe the process is the transitive property. So let me write out the equations, and then we can take a look at it together. Okay, so here's my equations. Now what I want to point out here is that we have a y right here. We have a y right here. It's the same y. Those are the same, right? Just like here, this b and this b were the same. So if I'm saying that this 3x minus 7 is equal to this y, and this negative 2x plus 3 is equal to that same y, then what can I conclude? Right? And so here's kind of, we can write it using the transitive property, right? If 3x minus 7 is equal to y, and negative 2x plus 3 is also equal to y, then what can we conclude? What can we conclude? If both of these things are equal to y. Look, when both of these things, A and C, were equal to B, we could say, oh, well, those two things are equal to each other. If Bob and Gary were both the same height as Jim, then we could say, oh, well, they must be equal to each other. So what we can conclude here is that these two expressions, this expression 3x minus 7 and this expression negative 2x plus 3, they must be equal to each other. So I'm going to write 3x minus 7 equals negative 2x plus 3. And it doesn't matter what order. If I could put the negative 2x plus 3 first, equals 3x minus 7. Okay, and so what I'm going to do, I'm going to just draw, I'm drawing a straight line just down for the rest of the page, and I'm just going to kind of write the steps over on this side while I do them on the left. So you're going to set the two expressions equal to each other. Okay, this is what this means. When you say to set things equal, that means to put them on either side of the equal sign, to say, oh, these two things are equal. Remember, these expressions, they were both equal to y. So that's why we could say, okay, well, if they're both equal to y, then they must be equal to each other. The other way of thinking about this is saying, we could kind of just use that same substitution brain and say, okay, well, look, like if I know y is equal to this, then I'm going to take this y and I'm going to substitute this expression in, right? I'm just going to substitute this in. So we could kind of use the same mindset we used previously with substitution, where I'm just going to substitute this in for the variable that it's the same as. Either way, you end up with this equation. Okay, and the next thing we're going to do is we're going to solve this equation. And what variable do we have in that equation? What variable are we solving for? We're solving the equation for, we're solving the equation for x, right? We don't have any y in this equation, so we're solving the equation for x. So how do I do this? Well, I notice that there's variables on both sides, right? We don't like that. So I'm going to try to get all the variables to one side. So I have two choices. I could subtract 3x from both sides. That totally works. And I'll end up with negative 5x over here. I like to keep my stuff positive. So what I'm going to do is my other option, which is I'm going to add 2x to both sides, right? Because I'm going to cancel this. And why? Because I want all the x's on one side of the equation. So I can either cancel them off this side, which would have been totally correct, or cancel them off this side. So I get over here 5x, and I'm bringing down minus 7 equals, now this canceled, right? Negative 2x plus 2x is 0, so it's gone. This equals 3. Now I need to get x by itself. So I'm going to first get rid of this minus 7. And then x is being multiplied by 5, so I'm going to divide by 5. And I get x equals 2. Okay, so I've done step 2. I've solved the equation for x. Now, my step 3, because remember when I'm solving a system, this is only half my answer. I have my x value, I need my y value. So what I'm going to do is I'm going to take that x value. Now normally what I do is I plug it into one equation and then I check it in the other equation. But we're just going to kind of combine those two steps into one. You're just going to plug the x value into both equations to get y. Now, you should get the same y value, right? There's only one correct x value and one correct y value. Okay, and by doing this, you're already checking your answers, right? By plugging into both. You are checking your work, right? And how should you check your? How are you checking your work? You should get the same value for y. Right? If you get two different values for y, you know you've made a mistake somewhere. Okay, let me show you what I mean. So my two equations were, these are my starting equations, y equals 3x minus 7, and y equals negative 2x plus 3, and I'm substituting back in. Y equals 3 times 2 minus 7. Y equals, right? I'm substituting in, instead of an x, I'm substituting in 2. Because I know that x equals 2. Okay, now hopefully when I do the math, I get the same answers here. 3 times 2 is 6. And then 6 minus 7 is negative 1. Negative 2 times 2 is negative 4. Negative 4 plus 3, same as 3 minus 4. And that's negative 1. So perfect. I have my x equals 2 and my y equals negative 1. So my answer is x is 2 and y is negative 1.